Hi, my name is Dr. Bhairavi Shankar. I am a planetary scientist and member of the RASC Toronto Centre. As we celebrate Mars opposition, I'm excited to highlight many amazing facts and details the planetary community has learned from several decades of Mars exploration. The fascination and observations of Mars has its early roots all the way back to 1659. The Dutch astronomer Christian Huygens made the first recorded drawings of Mars. What he drew has almost perfect resemblance to what orbital satellites have recorded at a global scale. Advances in technology throughout the 20th and current 21st centuries have resulted in many missions to Mars over the past 60 years. Since the 1960s, humans have robotically explored Mars more than any other planet beyond Earth. Currently, 8 missions from the United States, European Union, Russia, and India are actively orbiting Mars or roving across its surface. But getting safely to the red planet has not been easy. Of the 45 Mars missions attempted since 1960, nearly half had had some component fail to leave Earth, fall silent en route, miss orbit around Mars, burn up in the atmosphere, or crash onto the surface to die prematurely. This map lists all the mission locations. Missions to the equatorial and northern hemisphere have been successful almost all of the time. The southern hemisphere hasn't had as much success in landing rovers. Nonetheless, satellites orbiting the planet have revealed a lot of information about our red planet that guides the scientific community in understanding Mars. Details and images that I will cover for the remainder of this talk are all derived from a combination of missions, including Viking, Mars Odyssey, and Mars Reconnaissance Orbiter. NASA's Viking project was the first US mission to land a spacecraft safely on the surface of Mars and return images of the surface. Mars Odyssey holds the record for the longest continually active spacecraft in orbit around a planet other than Earth. The goal of this mission was to map the chemical and mineralogical makeup of Mars as a step to detecting evidence of past or present water and the volcanic activity. NASA's Mars Reconnaissance Orbiter, or MRO, is the second longest lived spacecraft to orbit Mars. The primary goals are to map the Martian surface with a high-resolution telescopic camera, or HiRISE. This would help in selecting future sites for landing missions. One of the early findings from imagery collected by HiRISE was the presence of liquid carbon dioxide, or water, on the surface of Mars. The spacecraft has many other instruments that can capture chemical composition of rocks and a radar instrument to measure the presence of underground liquid or frozen water in the upper kilometer of Mars's crust. So, what have these missions informed us about Mars? We have learned that the topography of Mars is very different from Earth. Mars's northern and southern hemispheres are wildly different from each other. The planet's northern hemisphere consists mostly of low-lying plains. The crust there can be just 19 miles thick. The highlands of the southern hemisphere, however, are studded with many extinct volcanoes, and the crust there can get up to 62 miles thick. Because of the density of impact craters, scientists believe the southern hemisphere to be far older than the northern plains. Much of the heavily cratered southern highlands date back to the period of the heavy bombardment, about 4.1 to 3.7 billion years ago. This animation shows major features of the Martian surface. We start from the largest volcano, Olympus Mons, and the Rift Valley, Valles Marineris, and then head towards the South Pole. We pass by an impact feature, Helios Basin, and eventually end up at the Martian North Pole. The 2020 Mars Opposition event presents an excellent observation to see many features on Mars in quite some detail. Unlike the 2018 event, when a planet-wide dust storm covered the entire planet, it was hard to see anything. But this year's opposition event gives observers clear views of the surface features. If we look at Mars this week, we will see a mix of bright and dark features on the surface. The lighter regions generally represent desert areas, while the darker regions are exposed rock. Here's an overview of what we know of some of these observed regions that are visible during Mars opposition. The South Polar Cap will be bright and easy to spot this week. The seasonal caps are composed of carbon dioxide ice. In 2004, the European Space Agency's Mars Express confirmed that the South Polar Cap contains water ice. The cap changes shape with Mars' seasons. During the summer, at the South Pole, a small residual cap of carbon dioxide ice can remain. At both poles, the ice caps overlie thick layered deposits of interbedded ice and dust. That is about 3 kilometers in thickness. The layering is interpreted to record the climate history of Mars for at least the last 7 to 100 million years. The polar layered deposits are some of the youngest geologic units on Mars. The next area that is visible is Certis Major, Planum. This is a dark spot located in the boundary between the northern lowlands and the southern highlands of Mars. The V-shaped form of Certis Major indicates a low-level shield volcano. The central part is dominated by dark dust and lava flows. These lava flows are partly bounded to the east by a large depression, Indus Basin, which contains smooth plains, and to the west and north by heavily cratered and moderately faulted highlands. Next, we see Helios Basin. This 2,300 kilometer diameter basin is one of the largest impact craters in the solar system. Topographic data captured by the Mars Orbiter Laser Altimeter indicates that the basin floor is about 7 kilometers deep. The altitude difference between the rim of the basin and the bottom is over 9 kilometers. The high atmospheric pressure at the bottom of the crater floor suggests that liquid water might exist. It has been theorized that a combination of glacial action and explosive boiling may be responsible for gully features in the crater. High-rise images reveal very strange landforms on the floor of Helios. Materials appear to have flowed in a viscous manner, like ice. The floor of Helios Basin is often obscured by atmospheric haze and dust, but it tends to be quite clear in the northern spring and southern fall. The shapes of many features in Hellas Planitia and other parts of Mars are strongly suggestive of glaciers. The surface looks as if the movement has taken place. Based on observations captured by the radar instrument SHARED, scientists believe that snow and ice accumulated on higher topography flowed downhill and is now protected from sublimation by a layer of rock debris and dust. Impact events have continued well after the main Hellas formation event, and they can reveal more about the geological history of the region. Crater shapes reveal the presence of ground ice. The area around craters may be rich in minerals. The heat from the impact event interacts with the ice, melting and causing alterations, leading to ore-like deposits. Knowledge of these areas can help with future human exploration. We now look at Terra Samaria, originally called Mare Terranum because of the assumed nature of there being seas. Spacecraft photos reveal this area to be old and cratered plains rather than a sea. It contains the large volcano Tyrannus Mons, one of the oldest and perhaps most complex volcanoes on Mars. This area has also narrow depressions, or troughs, called fossae. Troughs form when the crust is stretched until it breaks. The stretching can be due to the large weight of a nearby volcano. The breaks leave steep cliffs along the sides, as the picture on the right captures. Sometimes a crack or fault can widen or dilate. This widening causes a void to form. When material slides into the void, a pit crater forms. While pit craters are not observed on Earth, the closest feature can be sinkholes. The formation of pit craters and sinkholes, however, are very different. Terra Samaria is one part of the heavily cratered southern highland region of the planet. Terra Samaria is the location of gullies. Gullies occur on steep slopes, especially on the walls of craters. The most popular theory of formation involves liquid water coming from an aquifer, melting at the base of old glaciers, or melting of ice in the ground when the climate was warmer. Terra Samaria is also the location where several dunes have been observed. Observing dunes on Mars can tell us how strong the winds are, as well as their direction. On Mars, dunes are often dark in color because they are formed from the common volcanic rock basalt. Terra Samaria is also known to be the location for several old glaciers. Many features on Mars are believed to be glaciers with a relatively thin coating of debris that keeps the ice from melting. The next region is Eridian Region, located at the boundary of Terra Samaria and Terra Serenum. This includes exposures of some of the most ancient terrain on Mars. In addition to containing some of the most ancient crust on Mars, it contains a large basin that was once likely filled with water. Scientists are using imagery to learn more about how long the lake existed, the water chemistry in the lake, and looking for more deposits in similar regions. Results from studies suggest that the Eridian Basin contains a complex suite of alteration minerals that likely formed in a hydrothermal seafloor volcanic sedimentary setting. As you continue to observe Mars, you will notice that the landscape has started to change. Eventually, you will start to see a lot of the volcanic regions known as Tharsis, where Olympus Mons and several other volcanoes are nicely in view. Valles Marineris can also be seen. It's the giant valley that started as a rift system, but then got eroded through movement of water. 60 years of Mars exploration show us that diverse surfaces exist on Mars, and these provide clues on the geological history of Mars. We can see the interactions of lava flows and floods of water in the Elysium volcanic province, as the image on the left. We can see small meandering channels in the stream beds of a larger channels, as seen in the center. We can also see the light tone layered rock outcrops in areas like Hellas Planitia. These light tone materials are likely sedimentary rocks that were deposited early in Mars's history. As I wrap up this talk in highlighting what we've learned from Mars, I would like to mention that you can also explore a lot of these surfaces and learn a little more of various features on Mars right from home. For example, you can use Google Earth and switch over to the Mars view to look at all the areas that I have mentioned, to look at the topographical differences on the surface, and to also see where missions have gone and explored. If you're curious and are interested in helping out the scientific community in looking at large data, I invite you to look at Galaxy Zoo. Particular to Mars, there are 2 projects that you are welcome to join. With that, I wish you clear skies, happy observing, and thanks for tuning in.